Hi guys, let's talk about section 7.5. Now this section kind of gives us a bit of a break and it lets us reflect on 7.1 through 7.4. So this is coming just the right time. We've been dealing with some heavy topics in 7.1, 7.2, 7.3, and 7.4. So it's nice that we get a section where there's nothing new. So what is this section then? So we call it the integration strategy. At this point, it's just going to be, the homework is just going to be a mix of all of the different techniques that we have learned so far. And in a very real sense, you could say we've learned every integration technique at this point. We're going to see some other different approaches to integrals in the rest of the chapter, but it's definitely going to be a different way of thinking than what we've been doing so far. Okay, so the integration strategy, the idea is let's look back at those four sections, and we'll even include U-Substitution, and just kind of think, okay, so looking at an integral, like what might tip us off as to which method to use. And I'll tell you right now, on your exam, there will be some questions where I tell you which method. Okay, so I might say, integrate using integration by parts, or integrate using a trig integral, or something like that. But there will also be questions where I do not specify, and so you'll need to determine which technique is appropriate on your own, and that's definitely a big part of the course as well. There will also be questions where I will simply ask you which technique would be appropriate, and you will not actually have to integrate that. You just tell me which technique fits the situation. Okay, so we're about to go through and just kind of discuss each of the five. I'd like to draw your attention up to the top right corner. So on my syllabus, or on the learning resources page, I talk about this pyramid, the pyramid of learning. And so learning is always built up in these three stages. Okay, so you come into any new topic. I mean, certainly math, but anything new that you're learning, you're going to come into that with certain basic expectations, right? So obviously the basics in this course is all the other math you've learned up to it to this point, in particular Calc 1. Okay, so you're coming in with Calc 1, and we assume that this foundation is strong, and then we're going to build from there. Now, obviously, we know there's cracks and holes in this, but we need to be attentive to kind of fix those things. But okay, so we're coming in with the basics. At this point, we've even gone through what we call the struggle. So we're building up the next layer, and it is tough. And as we build up that next layer, all the weaknesses in the basics get exposed, and we got to address those things, and we got to keep learning new stuff at the same time. Okay, any new thing you're learning, this is how it works. And then you start to reach the pinnacle. So you've struggled for some time, and this, it's kind of tapering off. I guess maybe the struggle, it's becoming less of a struggle the more you practice these. Okay, so you get better at recognizing these, you get better at executing integration by parts, and all the other techniques and that sort of thing. Okay, so by the time you get to the end of the homework for 7.1 through 7.4, and you've taken a quiz on these things, you should be moving up, and the struggle is not, it's not quite as much of a struggle as when you were very first introduced to them. Okay. And then we reach the stage where we need to refine. And that's kind of the beauty of 7.5. We're going to look back and we're going to really hone how to recognize these things, and then exactly what we're looking for. We're kind of assimilating all this information. Okay, let's start down the list. So we're going to include U-Substitution as number one, even though it's not part of this course. That's still an integration strategy, and we certainly use it a lot when it comes to the new ones. But I'll say, okay, so we need to be able to recognize when a U-Substitution is needed. I'm not going to say anything more about that, just because that's a Calc 1 idea. Okay, so then when we get to by parts, okay, well, certainly we need to know the integration by parts formula. Integral of u dv equals uv minus integral v du. There's certain kind of ways and fun ways that people memorize that formula. I never thought I had to. I think there's like some limericks out there, and I don't know what they are, but um, that they're kind of nifty. I'm sure you could find them out there. Um, I never personally used any of that. Integral u dv equals uv minus integral v du. Okay, so we need that. Okay, so now what can we draw out of that? Well, certainly by parts, right? If we look here, we're thinking of, a product of two things, right? U times dv. So if we see a product in an integral, well, that's a tip that it's very likely to be integration by parts. And then certainly if we can identify, one of those as, we could maybe easily take an antiderivative, like the dv is kind of more of the tip. If I can do an antiderivative there, and then I can kind of think ahead, okay, will the v times du, when I multiply those, where's that going to get me, and does it get harder or easier, that sort of thing. Okay. Then we have trig integrals. Trig integrals are probably the easiest ones to spot because they're completely trig. A trig integral is always completely trig. So, right, we've got these two big forms, powers of sine and cosine, or powers of secant and tangent. Sorry, my writing's a bit sloppy here. Obviously, we saw problems that don't take those forms, but a lot of them do. And whatever it is, it's completely trig. Then we had trig substitution. And although trig is still in the name, it's a very different look, right? So what will a trig substitution problem look like? Well, it will involve a root, most likely. And so my example here has that square root, right? So it might be in the denominator, a lot of times they are, but it could be in the numerator or wherever. So it'll have a root. Sometimes you'll see, a quantity like this raised to the 3/2. Well, that still has a root because of the, raising to the 1/2. And we tend to see a lot of perfect squares, right? So things like x squared, 4. Sometimes you see, maybe like 25x squared, right? Like perfect squares happen a lot. Also, and then you might just see like x's or other powers of x involved in there as well. Okay. But a trig substitution, we know, does not involve any trig in the original problem. The trig integrals have the trig. The trig substitution will end up using trig, but the original problem doesn't have any of that. Okay. And then finally, there was partial fractions or partial fraction decomposition. So what can we recognize there? Well, it's going to be a rational expression with a factorable denominator. Okay, so here my example is 6 over x squared plus 3x plus 2. So we see this and you're like, I could factor that denominator. Sometimes they're factored for us. Most of the time they're not. But then we know, okay, I can set up the partial fraction decomposition and, end up getting the system of equations and go from there. But then there's also number 6. And number 6 kind of throws another curveball at us. There could be a combination of these things. So maybe it begins, looking like a partial fractions, but then, maybe one of the other ones gets involved somehow. Maybe it begins as a by parts, but then the new integral ends up needing partial fractions, right? I mean, that's possible. Certainly the trig subs almost always fall back on trig integrals. So a trig substitution, those new trig integrals, pretty much always you need some kind of technique back here. So you could sort of argue that's a combination. Although I wouldn't, I would just probably call that a trig sub problem because that's just how they are. U-substitutions, very, very common to get combined, right? You could have a U-substitution involved with a partial fraction. You could have a U-substitution involved with a trig sub. Right? I mean, that sort of thing happens. You could combine by parts and trig integrals, right? I mean, so, and that's where it really, really gets difficult for sure. Okay, so what I've done for you guys, I don't have any examples to walk through because, you really learn these, just kind of looking at them one at a time and then trying to piece it out. And we've certainly done enough practice from each of the varieties. But what I've done and what we would do in class if we were meeting together, I would just put up